Hi, Anna. How are you? Just waiting for you guys to join in.
Hi, how are you?
Good, good. We'll wait for a couple of minutes. Hi, Paul.
I don't know if my microphone's working. Hopefully it is.
It is working. It is working. Yeah.
Of course. Thank you. I'm just checking out your blog while I'm waiting.
Okay. blog.dvcompare.com. Yeah. Thank you.
I'm adding it to my feed reader now, so hopefully, at the very least, you'll get one extra subscriber out of this.
Yeah. This meetup group was dormant for a long time, and I thought, okay, and I've been paying the fees for that, and I thought, okay, let us do something.
Yeah, and to see, and it's a lovely topic.
Yes.
But
Yeah.
in that it's a niche topic as well. So
yeah, it is really lovely. It's not in the sense because AI is eating up the world, and explainable AI. People are working quite less on that. Just like they are treating it like a GDPR or something like that. Okay, it's a regulation. It's much more than that. It is in search. It is in subscription. Everywhere it is there. Yeah.
And to explain, sorry, and I'm very niche as well, so I'll explain. I've written a book. So I've written 2 books on rules-based AI.
Rules-based AI. Okay.
Yeah, through rules and now Apache Key, and the team were just about exploring SHAP and Lime at the time. So this is about 3 years ago, and that's the only exposure I have to it. So it does get niche very quickly. Rules is, but everything that. So people should be paying more attention to it. I'm sure they will in the future, but I think most people are just at the ChatGPT equals AI stage, and we know that's not true. But
yeah. Okay. Yeah. So rules was. Can you spell the spelling? What is that? RULES?
Yeah. So Drools is DROOLS.
Yeah, I heard about it. Rules. Yeah.
Yeah. And now it has since been adopted. It was a Red Hat stroke IBM sponsored project, and then it is migrating over to Apache. So it will become Apache Key, KIE. They're hoping to get the first stable release out on Apache in the next month or 2. So
yeah. IBM also has one XAI product called, I think, IXAI or something.
Yeah, I saw something.
Yeah.
It was one of the online groups, and I think they're doing some event or webinar on it next Thursday.
Okay.
So, I'll go back in and I'll dig it up because
okay.
Just I did not expect to be. So let me explainable. No, that's the wrong one, and I archived it off. So let me look at all mail.
So this IXI is not derived from Drools, right? It is different.
Yeah,
Drools from
two very different. Drools is more. It's a different approach to the same problem.
Rules engine, was it the rules engine? The earlier rule.
So, but where the generative AI comes in, where I think the team is going to land, is you take your documents, you generate your business rules from them, you can inspect the business rules to see if they're actually accurate, and then it's those business rules that get executed. So it's 100% same result every time. So that's a
Yeah, yeah.
different way of approaching. And I know, yeah. So
I
I'm,
think
I'm
it is a rules engine, business rules engine. I think
absolutely.
Rules is a leader, and I think another one was iLog or something, iRules or something.
I
Uh,
log is another commercial
yeah,
competitor
correct,
to
correct.
it.
Yeah,
Yeah,
yeah.
yeah. So yeah,
When we were
I
working,
think, and again, it's niche. You know, yeah, that let's call it niche. Yeah, but
okay.
for this, yeah, I'll let you carry on with the
Yeah, yeah,
session,
yeah.
whichever way
So,
you want to
are you
do.
guys able to see the deck?
Yes.
XAI musings beyond SAP and Lime.
Yep.
Yeah. Okay. So just I think those who are not familiar with XAI, just wanted to say that what is a black box AI, which is the current perception, wherein you get an outcome, but you don't know why the outcome has arrived. Um, uh, so uh, so you get as people get used to AI in their day to day, every minute mobile burst or a notification, they are more and more demanding. What is the reason behind it? And that reason has to be consistent. And AI is based on is based on probability, right? So to be consistent is a very big challenge. Consistent in the sense deterministic, why it happened for my case, and what should it be done, should be done, so that I can change the outcome, or I can get a well granulated reason for this. So there, I've been working on a SHAP and Lime. So it is more analytics. SAP and Line, they provide more analytics, or why it happened. Like for example, a diabetes detection. Why a person was diagnosed with diabetes? This. Yeah, he had insulin. Yeah, he was fat. He was this. But it doesn't give a solution. It doesn't give a counterfactual. So that's where I thought DICE, it was popularized, I think, 2020 by Microsoft. I've used a lot. It provides solutions instead of analysis. So, so and it provides the range as well. What range you can change in the outcome. For example, in a diabetic patient, let's say you reduce a weight by 3 kg, you reduce intake of sugar by this, you have this insulin number as this reduced by 10%, then you get into a normal range. So it does a what if analysis, like we used to do traditionally in stocks, right? Why it happened, what it would have, why we could not get more gain or less gain, or why it was a loss, or what is the analysis behind that. So it does a nice what if analysis. So um, that looks to be promising, and I have been using that. So if you see this XAI libraries, so it generally, if you know about a little bit of a history behind XAI, explainable AI, then it is very it gives a light, it gives a nice perception of where we are. So always I try to look into a little bit of history of technology, which one is latest, which one is earlier. It gives a nice perspective. So if you see here, 2016, we had Lime, SAP, and all coming. Then if you see Deep Explain Captum by Facebook, yeah, this is the one, AIX 360, Paul. So AIX 360 it is called. 2019 it was released. DICE by Microsoft was released in 2020, and then this Interpret ML has also been released by Microsoft in 2020, which is also has something called EBMs. But if you see if you see the core meat of it, the core methods still remain SHAP, LIME, and DICE. So counterfactuals and analysis by LIME and SHAP, and counterfactuals meaning what if analysis by DICE. For example, if you see Omni XAI, it's from Salesforce. It combines SHAP, LIME, and counterfactuals. So they take all the open source part of it and try to make it more robust, scalable. But the engine is still the same. So if you see how does SHAP and LIME and DICE differ, the SHAP has a it pretty much SHAP and LIME are both analytic, and they explains the why it happened, but not the solution, as I told earlier. And both have local interpretability, but SHAP has a little bit global interpretability. But there is one small difference between SHAP and LIME. LIME needs aggregation, and SHAP and LIME in terms of feature part. One does contribution, LIME does feature weights. So both are similar. If you say contribution and feature weights, both are almost similar. Yeah. And then there is DICE, which so here I can show you a working code. I think that will be better to understand. So let me share my screen. Any questions, guys? Tara?
No, not so far.
Okay.
No, it's good. Thank you.
So if you see this, so here the example, if you see this example takes one data set, almost similar, I will say similar for the sake of argument, a similar data set, and it does not a neural network. Neural network, we know, is, everybody agrees that it is a black box, right? But this one is machine learning, XGBoost. Machine learning in the sense it is you instrument the code. It's not neural network means it's all neurons, no image analysis, vision analysis, those sort of things. This is pure data points. That is called machine learning. In the sense, I want to just re-emphasize so that people have different meanings of the same terms, right? So this one is machine learning. In machine learning, this code, what it does is that we are applying all the three XAI libraries, SHAP, LIME, and DICE, and seeing, and we will notice how different it is and how useful it is. So DICE ML is a package which is a Python library. This is just a Python code. I have installed DICE ML and LIME here. And here what I have done is I have imported XGBoost. And so this first one, it does that import, and it does the generation of data. So if you see the income, this is doing a loan analysis, why a person was rejected for a loan. It does an analysis of that, and yeah. So income has I have created a random logic and clipping based on lower limit and higher limit of income, credit score, loan amount. I have taken 7 variables, and Then I have constructed a ground truth, put them in a data frame. Data frame is nothing but a list, and then added the features. Then I have trained, tested, a normal activity. So I see the accuracy as 0.955. So now what I do is accuracy is something like a F1 score, and now I pick up an applicant who has been disapproved of the loan. So here, if you see, when we pick up this disapproval, if you see this loan to income ratio, this estimate existing debt, he has a debt, and employment year is 4.55 and all. This is a disapproved applicant. Okay. So so what we do is that what we get with DiCE. With DiCE, you see this. You try to train the data, you model it, and then you put the same values, and then you generate counterfactuals, and you get this data frame. Okay, the income ratio, loan status, this. So then what is the action plan? So you put up the minimal range, and you fire up the query. You then ask for a minimal action plan, and this is the result. So it says this applicant has to his income has to be decreased by 1629. Credit score has to increase by 50. So this income decrease, we can put some immutable parameters as well. Don't increase the don't try to decrease the income, because nobody wants to decrease the income for this is so. And then age, we can change this to immutable, keep that as constant, because age cannot change, right? And income cannot change. So and then the loan amount and employment years and existing debt he can decrease, and then he can so this is giving a what if analysis of that loan. So I mentioned it. I know you can keep the immutable age. You can make it fixed. This is not done in this code, but we can do that. You can further constrain the income, how much you can income cannot it should do a minimal change of income, which is logical, right? And yeah. So I have the same thing done on Lime as well. If you see in Lime and SHAP, so this is a credit like data set. You construct the ground truth like you do in DiCE. I create a data frame, train, test it. So here the library SHAP has various forks. This is called tree SHAP, which I find it useful. So here.
Sorry, Shini, are we looking at a different screen? Because I'm just seeing still the DiCE notebook.
Oh yeah, yes. Sorry.
Thanks.
Thanks for that. So yeah, so this one is Lime and SHAP, but on the same data set. Okay, so here if you see, just I have installed Lime, and then I have constructed the same data set, random, using NP, NumPy random, and then clipping, and then I have constructed the ground truth, and then created a data frame like I did for that DiCE. created features. Features are the same as this, as the columns, the simple ones, right? And then trained it. So now you pick up the patient, pick up the applicant, and if you see this analysis for this applicant, which is similar to the DICE one, it shows that what is the weight of each, why it was rejected. So age was one of the big factors. Loan amount was the next big factor. So that shows that it gives a you can they call it a waterfall model. So if you see the line part is not that intuitive. SHAP, another one big difference between SHAP and Lime is, Paul, for you, SHAP will always give you deterministic answers, so consistent answers. Although we are taking an input as random here, but if it was not random, then it will give a consistent answer. But Lime is more little bit on the probabilistic end. So in Lime also we are trying to do this. They have a Lime tabular explainer class, imported that. So here it says why it was disapproved. So 0051, 0048, 0005. So it gives a weighted score plus and minus. What was the reason for reduction, for the rejection? Is this clear? Or I have another example with diabetes, which is on neural network. You have any questions? Or
no
question. That looks good.
Okay, so this the next one. This one is neural networks. So this is where the crux is. Even the tech guys will agree that it is a black box. Neural network as the fundamentals are itself a black box. They always call it convolution neural network, RNN, LSTM, CNN, transformers, all are black box. So for example, ChatGPT will not tell why it can. In ChatGPT also you see, right? When you ask for an answer, it will give answer once. It will give one answer. After that, it will give another answer. After that, it will give another answer, because it's all based on probability. But at least if it gives a links of why it came to that conclusion, then it would be nice. That is not there. So.
Or even said when it didn't know.
yeah, correct. Yeah, it should say that I didn't know. Yeah, correct. So these are what will happen is, with this we will become fully dependent on a system which is giving some black box type answers, and human mind is always it's not a dumb mind, right? Like compared to like it can relate to things like 10 years old, 15 years old incidents also we can think, and we can take that lesson and act on it, right? So if you see ChatGPT, it can you have to tell it that it has to be same format. It is good at understanding text. That's it. So I will say, but it is not good at understanding memory at the level of human beings, and the intelligence and what I found in ChatGPT also, whatever you ask, it will give you. It will not come up with a let's say come up with 5 more ideas which are more creative and funny. So it will always give the same sort of funny. Let's say you ask for insurance case scenarios, it will always go to insurance claims and fall into that. So something like that. Yeah, it is quite biased if you use it regularly. So this neural network thing, let's go back to this. So here, sklearn, scikit package has this MLP classifier. You have to import that classifier. It is imported to this one, MLP classifier. This is the key one. So it is imported, and then the same NumPy random and clipping I have done, and I imported this classifier, but now it is running on a neural network, which is the MLP classifier. MLP classifier is basically saying it is classifying, categorizing the data. So it has picked up a patient. Now it will try to pick up a patient. So this is the patient it has picked up. And he has diabetes. We have picked up a patient which has a high risk of diabetes. And then we run SHAP on that. So he has all this 0.18, 0.04, which is contributing to his 0.868 value of. So it says that it shows what is what is the problem, but it does not give a solution to that. So Lime also, it gives weight, in a text form. You have this issue. But if you see DiCE, you run the same code as earlier. You generate counterfactuals. So it's what is the minimal action? This is the fun part. Minimal action change. So it says decrease glucose by 2872. Glucose 2872 is okay, right? It's not. It looks intelligent. Blood pressure decreased by 0.7. This looks to be a very small change. Skin thickness. How do you increase skin thickness? But I don't know. Insulin decreased by 182. BMI decreased by 22. That's big. This age we can make constant, which I have not done, but yeah, diabetes pedigree decreased by 0.5. So this type of solutioning is given by DiCE. That's why it is very popular. And then this is there is a side-by-side comparison. I did not find that much meaningful. This is the side-by-side table comparison. SHAP gives a weight 0.18. Insulin was, this is the problem. That's why he got diabetic. Here it says it has a Lime weight, which is a minus and plus of the median. So it is plus 0.1, and he has a minus in some places. So it says that the BMI is okay. Minus 0.00 is basically 0 only, but insulin is the problem. So basically SHAP and Lime convey the same thing. One has a positive, negative, another has increasing thing. But if you see this, it gives absolute rank as well. Yeah, but yeah, 1, 2, 3, 4, 5, 6, 7. It gives a rank as well. Yes. But DiCE is focused on changes to reach the other class. Yeah, that's it. Yeah, I think I will share this Jupyter notebooks and deck, and we'll be in touch.
That's amazing. Thank you so much, actually. That's really fascinating.
Where do you work, Anna?
Oh, I'm just a lowly junior data scientist at Bank of Ireland.
Okay, good. Okay.
So your first example was very interesting, and this example as well, to be honest, is excellent as well. So yeah, I'm fascinated, and as you say, the explainability of some of these needs to be improved. So
yes,
yeah. Now I just need to find out if I can get all these packages at work.
yeah. This is
You're-
Google Colab. Is very. It's all online. You need not install anything. This is Jupyter Notebook on online. So you can save it
Brilliant.
on your Google Drive, and that's it.
Thank you.
So if you see this, if you open this Colab, so you can see it comes in the drive.
Oh, brilliant.
And when you open that, it will open that this window.
Yeah. And you probably have the same problem I do. You can use stuff on the internet, but your data, the really interesting data, is within the firewall, and it's trying to get both of them into the same place.
Mhm.
That is a big challenge. That's a big challenge. Yeah. Now and with cloud and all, people have been moving the test and QA systems, but still there is a big resistance. Yes, yeah, and that is rightly so. Yeah.
Yeah.
But thank you for running through that. That was very clear. So yeah.
Thanks, Paul.
Okay.
Thanks. We will be in touch.
Thanks again.
Thanks,
Thank
Anna.
you.
Thanks.
Brilliant.
Bye.
Thanks.
Thanks,
Bye.
guys. Bye.
Bye.